All right, so this is the second day of Unit 13.2, which is about series. Today, our focus is really going to be on changing the index of a series. So yesterday we actually did summations and writing the summation given a series, and now we're going to actually work on just changing that index of the series. So just a quick reminder what the index is. The index is the values that can be substituted into the summation expression. All right, so if I'm looking at the summation here, the values that can be substituted in come from the value underneath the summation or the sigma and above. So my starting index, or the lower limit of what I can substitute in this case, is 1 because that's the starting amount. The ending index is 8. It's the upper limit, the highest that you can put in there. Okay, and the idea is, what happens if I give you this summation to begin with and you're going to need to change to something else? Well, an index, so the index above goes from 1 to 8. Okay, so we can plug in 1, 2, 3, 4, 5, 6, 7, 8. And this index really is just arbitrary. It can be changed, and that's going to be our focus today. If this is really arbitrary and it can be changed, how do you go about changing it? So if you want to change the index, then you must change the expression as well. You must change the expression so that the summation is the same in the end. Okay, so if we're going to go ahead and change that index, we're going to actually have to change the summation itself as well. All right, so now we're going to go through some of those steps on how you actually change the index and how that affects everything else as well. And we're going to go ahead and we're going to use example 1 as we go through these steps. So the first step is we need to write the expression for the first index in terms of the second index. Now, you might want to know what that means. Well, the idea is, right now, in the original equation, we had I is 1, and this was our original equation. But if we're going to change this index, that starting index, from 7 to 1, then we're going to need to change this as well. So the question that I always ask myself, and this is the most important part right now, is what has to be done to the new index to get back to the old index? So what has to be done to the new index to get to the old index? So right now, my new index is 1. So I always ask myself, what do I have to add or subtract? What do I have to add or subtract to the new value to get the old value? What do I have to add or subtract to the new value to get the old value? So in other words, if I'm going from this value back to my original value, what would I have to do? So what do I have to do to the 1 to get to 7? Well, 1 plus 6 is 7. And now I'm going to take that idea and I'm going to write it as an equation. And the equation really would be that what do I have to do to the new one to get to the old one? So the idea is the old variable should equal the new variable plus or minus the number that you were talking about. So in other words, in order to get back to I have to take j and add 6 to it. So I is equal to j, which is 1, plus 6. So this is how we write the expression for the first index in terms of the second index. So I was really equal to the 1 plus 7, so I was equal to j plus 7. So this is going to be the basis for how we change everything else. So this is the most important thing to figure out first. All right, now that we have that actually figured out, we are going to change the actual expression. So step 2 is to substitute the equation you just wrote into the original expression. So in other words, if I'm saying that I is equal to j plus 6, I'm going to substitute that into my expression to get a new expression. So originally we started out with 1 over 2i, but now I know that I is really j plus 6, so it's 1 over 2. Instead of I put j plus 6. Now once we have that substituted in, we're going to need to simplify it. So 2 times j is 2j, 2 times 6 is plus 12, and we still have the 1 over the top. So this right here is the new part of my new summation. So far for my summation, we have, just going to make sure you can read this at the bottom. So you have your summation symbol. We know that the bottom is j equals 1 because that's what our new index is. We know that our new expression is 1 over 2j plus 12 because if j is here, then j has to be in our expression as well. And then the last thing we have to work to change is going to be our upper index or our ending index. So we need to, for step 3, find the new ending index. Okay, and to me, the easiest way to do that, or the way that we find that ending index, is to use the changing index equation. Index equation. Use the changing index equation. So I'm going to bring back down my original summation, which was from I equals 7 to 14 from 1 over 2i, and we're trying to get to our new summation, which is here, right? So I'm going to use that changing index equation from before that we said was so important. So this here is really the basis of everything. We plugged it in to get the new expression. We're also going to plug it in to get the new index. So my expression was I equals j plus 6. Well, we were starting out with this top being 14, and since this is in my first expression, which has i's in it, this is really telling me that my I equals 14 here. So I'm going to put 14 in place of the I equals j plus 6, and then I'm going to subtract 6 to get j equals 8. So then that tells me that 8 is my top one. Now, so what we just did, we substitute it. Original top index in for the original variable. And then we solved for the new one, for the new variable. Now, I know that my new summation actually is this. So if I were trying to go from an index of 7 to an index of 1, then this would be my new equation. And the way I always like to check my work at the end is to look for, and I'm missing the N there, look for the pattern. Okay? So in other words, I want to double check that I actually did my work right. And the easiest way to do that is I look at the indexes. My starting index was a 7 and it went to a 1. So from 7 to 1, I had to subtract 6. Then I look to see, is that what happened here from 14 to 8? Did I subtract 6 to get 8? Yes, I did, which tells me that this is actually correct. If that didn't work, then I would know that this equation is wrong, which means the expression is wrong as well. So that's a really good way at the end to check your work. All right, so we're going to do 2 more examples together, and then you're going to try the other 2 on your own. So when you're looking at this problem again, remember our first goal is to actually write the equation, that base equation that we're going to use, right? So we have to write our base equation, or maybe I'll call it the base conversion equation. So in other words, we're going to do I equals D, and then we have to figure out what we have to do to D. So what do I have to do to D to get back to I? Well, D is a 1, so if I want to change a 1 into a 0, what do we do to change 1 into 0? Well, we'd have to subtract 1. So I is equal to D minus 1. Now this is the base conversion equation we're going to use to do the change of base for all of it. So now that we've got this equation, our next part is to actually write the new expression. So write expression. So our original expression is I to the 4th power. But now we're going to go ahead and we're going to take our conversion equation and substitute it in place of the I. So this is really D minus 1 to the 4th power. Now when you do this, make sure you're really careful about that, because a lot of you might want to take another step and actually FOIL this out. Don't do that. Just leave it the way it is and go ahead and put it into the other part of the summation. Now that we've written that part of the equation, the next step would be we have to figure out what should our new upper index be, because we need to figure out what should go on top of that sigma notation for our new piece. So the next part would be to find the upper index. Right? And in order to find our upper index, we're just going to use that base equation we wrote at the beginning. And remember, our I was originally 11, right? Because this was in the I equation, so my I was originally 11, so we're going to put 11 in place of the I. Oops. I actually wrote an I here when it should have been a 1. So this equals D minus 1, right? And then we're going to add 1 to each side to get D equals 12. And 12 should be that new upper index. Now I would tell you, I would definitely take another second here and actually double check to see that this actually works. So when I'm going from 11 to 12, we would have added 1, and we would do the same thing from 0 to 1. So that pattern stays consistent, which tells me that yes, this really was my base equation. So yes, this actually is my expression. So I can finally say that my answer is the summation from D equals 1 to 12 of D minus 1 to the 4th. So this is my new expression, my new summation with the new index. All right, so let's look over here to number 3. So the same basic steps are what we're going to take. So first we're going to figure out, we have to find our new base conversion equation, right? So in other words, since we're starting out with an I, it's I equals, we're getting to an M, so I equals M. And now we have to figure out what do we have to do to M to get back to the I. So what do I do to 0 to get to 3? Well, we would have to add 3. So I equals M plus 3 is the base equation that we're going to use to do this conversion. Now we actually need to write our new expression. So my original expression was x equals, or x to the 2i plus 3. But now we're going to take m plus 3 and we're going to put it in place of the I in this equation. So we have x equals, or x to the 2. Instead of I, it's m plus 3 in the parentheses plus 3. Now, this expression we actually need to simplify. So we're going to go ahead and distribute this in. And we'll get equals x to the 2m plus 6 plus 3, which becomes x to the 2m plus 9. So x to the 2m plus 9 is my new expression that goes into that summation. And then lastly, again, we're going to have to find our new index, our new upper index. And the way we do that is we start out with the base equation, I equals m plus 3. And in this original summation, my upper index was 9, and the I was what was in this. So this is telling me I is 9, so I'm going to put a 9 in place of the I. And then we're going to solve for m, and we end up with 6 equals m. So that tells me I'm going to put 6 up here. And before I write my actual final answer, we're going to just double check. To get from one to the other, from 9 to 6, we subtract at 3. Would that work here? From 3 to 0, yes, you would subtract 3. So that tells me that yes, this base equation really did work, and yes, this actually is the expression, and yes, this is the upper index. So my final summation with the new index is from m equals 0 to 6 of x to the 2m plus 9. Now you need to try the last two problems on your own and be prepared to go over it in class.